everyone. This is Rahul, and this is our final project report for the CS-620 Intro to Data Science and Data Analytics. So my team members and team details are myself, Sahiti, and Pratyusha. So our topic is Alzheimer's disease and healthy aging. So let me give you a brief about Alzheimer's disease. Alzheimer's disease is nothing but a form of dementia where the patient has a short-term or long-term memory loss with the degeneration of cells. So these cells turn out to be numb in the brain, and the person's brain cannot function anymore until they die. So the reason for us choosing this topic is that in the public health sector, dementia and Alzheimer's disease has been talked a lot, but there is not enough data or data analytics or even data visualization techniques to prove that Alzheimer's has different causes and different reasons for its occurrence, recurrence, or non-occurrence. So let's move to the dataset details. So you can find my dataset in this catalog data.government. This is provided by government of the United States, and it has data from all over the United States, ranging from different ages, and it is found out through using different surveys. So what's our end goal from this project? So our end goal would be predictive analysis of how and why Alzheimer's disease might occur to some patients, geospatial data analysis using choropleth graphs or geospatial data, in fact, where you can see that what are the reasons that in a particular area the Alzheimer's disease is being more occurred, or comparative or behavioral study in a certain age group or certain gender if Alzheimer's disease is more common, policy impact of socioeconomical research, and temporal trend analysis using multi-line chart to show or see the trend of these. So the part of data cleaning is done by my friend Pratyusha, and she's going to explain about it along with the other stuff that she has done. So let's move to the graphs. To generate all these graphs or visualization or analytics, I've used Python as my language, and I've included multiple different libraries which has helped me to generate these graphs or perform these algorithms. So one of those is Plotly, which helped me in generating the interactive charts. This was suggested by one of my friends, Sahiti, and she has also used this extensively throughout this project. So this Plotly is nothing but a library which is used for interactive charts. And I've also used this scikit-learn for performing algorithms like k-means clustering and k-neighbor classifier and pre-processing algorithms. So these are all the required libraries that we are going to use throughout the process, and it includes regular libraries like NumPy, Pandas, Seaborn, and Matplotlib. But it also has some extensive libraries like sklearn, the simple imputer, column transformer, etc. So here we are just loading the data set and moving on to the next process in.
Hello everyone, this is Pratyusha. My contribution in this project includes two parts. First one was the data cleaning part. As we all know, data cleaning plays a very major role when we are working with data sets. So when I took this data set, it consisted of around 250,000 records and 39 columns. So I have used Python to clean the data. This is my data cleaning part. Firstly, I have worked on the missing values. I have removed all the columns which were having the missing values. Then I made sure to convert low confidence limit and high confidence limit columns into numeric types, so it will be easy for me to access them. Then I have removed the duplicate columns as well, duplicate columns and rows. So after this, my main focus was to filtrate the states, so it will be easy for me to access the states, because my main focus was on covering every state, so filtration of the states was much needed in my case. So after the data cleaning process, my main focus was to check how this disease prevalence vary across different demographic group, like according to the age or gender, how this disease increases or decreases. So my main focus was to work on the gender part. So I took two agendas, one is male and female, and to check how the disease symptoms were more in male or in female. So for this, I have chosen high confidence limit to be the best for the bar chart. For this, I have chosen the column as mean value of the high confidence limit. The reason to take the mean value, because the confidence limit measured throughout the test was supposed to be unstable because a person might be confident at some point and might not be confident at another point. So to make sure of that, I took the mean value of it. As we can see, this is our bar graph. Pink represents female and blue represents male. So in every state we can see that the confident level of female is higher than the male. If we take any particular state, it's clearly shown the confident level of female is higher than the male. So by this we can prove that the prevalence way across different demographic group for this disease is true. It does differ when we compare female and a male. So this is what I wanted to show by this graph. The next part will be continued by my friend. Thank you.
Hello everyone, this is Sahiti. This is my CS-620 Data Science and Analytics final project. In this project, my contribution is creating choropleth graph for geospatial data analysis. For this analysis, I choose choropleth graph to show high prevalence rates across the states of USA. I created this graph using Plotly, a JavaScript framework. And also, there is a research study that sunlight consumption is directly proportional to non-occurrences of Alzheimer's disease. Means if you get more sunlight in area, or if you are exposed to more sunlight, then according to research, the occurrence of Alzheimer's disease is less. As we can see in the graph, like the northern and northwestern parts receive more sunlight according to the map. In this map, the yellow states has receives more sunlight, and the people in these states are less affected by Alzheimer's disease. And when compared to other states, these states receives less sunlight, and the people here are affected more by Alzheimer's disease. The main goal of this map is to have higher or lower rates of people getting sufficient sunlight. And the next contribution to this project is predicting and calculating of model accuracy using k-neighbors classifier and preprocessor techniques. And for this model accuracy, I took clean data as a data frame and then created a column transformer to apply different preprocessing to different columns. And then I created a pipeline that first transforms the data and fits a model. This pipeline combines preprocessing with k-nearest neighbor classifier. After splitting the data into training and test sets, the model is trained and evaluated to calculate accuracy. As we can see, the accuracy is 36%, and with a 36% of accuracy on large data set, achieving a high accuracy can be particularly challenging. As this dataset is taken from surveys, the data can be unstable. So if regular data cleaning or data manipulation techniques might not give the desired accuracy results, but if the dataset is trained with more complex algorithms, the accuracy can be improved. Thank you.
So my contribution to this project has been temporal trend analysis using multi-line chart. So as you can see, I've taken three different topics: frequent mental distress, lifetime diagnosis of depression, eating three or more vegetables daily. And I've chosen four different states from the United States, and these represent four different corners of the United States. California being on the extreme left, Montana being on the north, New York being on the extreme east, Texas being in the south. So I've used Plotly and other libraries to generate this particular interactive multi-line chart. So if you can see in this drop-down, we have all the three topics that we chose. So in frequent mental distress, if you can see that all these interactive lines are pretty unstable, because frequent mental distress is something a person shows the signs for temporarily, but it does not last permanently. So you can look at the graphs that they are pretty unstable at every year and every quarter. When you move down to lifetime diagnosis of depression, just auto scale this. So you can see that the graphs are pretty stable, but the point is that the percentage of older adults who have lifetime diagnosis of depression have a higher chance of getting Alzheimer's disease. And that is why our data shows that the people who have lifetime diagnosis of depression may lead to Alzheimer's disease. Now, let's move on to eating 3 or more vegetables daily. If you can see that these curves are pretty stable and they're going down because it means that the person is taking good care of himself by eating regular food at regular intervals of time and taking care of himself. That's why these curves go down. So you can see the trend analysis using the multi-line chart in this particular graph. So my another contribution to this project would be the k-means clustering algorithm. So this was a bit of pain to generate as k-means clustering requires a lot of time to generate. I've used Seaborn here to generate these graphs. So these graphs have 3 different clusters. As you can see, I've used 3 clusters here and we can adjust the clusters as we need. But I've used only 3 because my data set is pretty huge and I need to compensate for the time and space complexity. So in my data set, I've chosen the topic column, which has different categorical data. And this categorical data has been pre-processed and then used by k-means clustering algorithm. And this graph has been generated. So in this, you can see that the year start, year end, data value alternative, location ID have been mapped using k-means clustering algorithm, even though they are an unlabeled form of data. And that is the reason we used k-means clustering. K-means clustering is used to find out unlabeled data and classify them into different categories. Now, coming down to the 5 major questions answered with respect to this analysis. So, how do different aspects related to Alzheimer's and healthy aging trend over time? So, I've shown my multi-line graph, which has 3 different topics in 4 different states from the United States, and you can see how the trend goes and how the occurrence and recurrence of Alzheimer's disease has trended over time. Now, coming to the next question, the Alzheimer's disease prevalence over different demographic groups. My friend Pratyusha has shown that different genders have different classifiers, which in turn give you different results when it comes to the occurrence of Alzheimer's disease over demographic groups. Which locations have high prevalence rates in Alzheimer's disease? As my another teammate has showed you that different areas have different sunlight consumption. So and there that particular area has the less occurrence of Alzheimer's disease. We've covered that. Now the 2 main beasts determining the accuracy of the model using K-neighbors classifier. So this K-neighbors classifier can determine a model's accuracy, and since we have a large data set and a lot of the data has been come through surveys, we need to use more complex algorithms and more complex data-based algorithms which can classify the data into more specific manner where we can get the more accuracy. Coming down to k-means clustering, I've used Seaborn as my primary source in this particular graph to show the plotting and the power of k-means algorithm for classifying unlabeled data. But we also have another 3D library from Matplotlib which we can use to visualize this particular k-means clustering algorithm even more nicely. But nonetheless, the k-means clustering has been proved using this particular question. Now, conclusion. So, in Alzheimer's disease, the data matters a lot, and so does in data analytics. We have gathered so much data that it is 200,000 records spread across 40 different columns. So this concludes that different data can be manipulated using different techniques like k-neighbors and k-means clustering and group down to bring down data analytics to a point where the researchers can get used to this and get a lot of help from this. Thank you, everyone.